Okay, before we talked about how to go about making some solutions, what some of the chemical and concerns are in making a solution, but today we're going to focus on the composition of the solution. So my question to start off today is, what are some situations where solution concentration is important to you? So hit pause now and think about that, come up with some examples, write those things down in your notes. Okay, so you should have a list of places where you've thought of solution concentration. Okay, and so as we get started here, this is what we're going to learn about today. A couple of units for concentration, 2 units specifically. When I think of solution concentration, and maybe this was one you came up with, when it comes to making Kool-Aid, solution concentration is important because lots of people use different amounts of sugar in Kool-Aid. Personally, I don't like a lot of sugar in Kool-Aid. You may use lots of sugar in your Kool-Aid. In fact, you may wonder how much sugar could you use in your Kool-Aid before it ends up just being slush on the bottom. And you may remember we had a term for that way back in the beginning of the year. We used the term solubility to describe the maximum amount of solute that will fit into a solution. Okay, so that's a little introduction and the use of some stuff we had before for concentration. But what we're going to do now is we're going to look at some actual concentration units that we can use. Okay, so before we do that, maybe we got to back up and see what does the word concentration mean. So why don't you go ahead and hit pause again and think about that. Okay, and so as I indicated in this picture, there is a large number of bicycles here in a small area, so we would say that there was a large concentration of bicycles. So that's kind of the use that we're going to have here. And when we're talking about a solution, the two things we have here are the solute and the solvent, as we saw before. So mass percent is our first way of expressing this. Mass percent is simply the mass of solute, that'll be in grams, over the total mass of solution, that'll also be in grams, also known as the weight percent. And kind of a symbol form, the mass percent will be the mass of solute, that will be in grams, over the total mass. You just add together the solute and the solvent, and you convert it to a percent, right? There are no example problems here. If you want to see example problems, there are videos of example problems on YouTube and the website as well. Okay. The second of our units is going to allow us to do things in terms of numbers of particles. And you may remember that when it comes to numbers of particles, we are going to measure things in moles. So our next unit is going to use moles, and it's called molarity. And molarity is the ratio of the number of moles of solute to the total liters of solution. So it's a lot like mass percent, and at the bottom is a total amount that you use. The units here will be moles over liters, and we can abbreviate moles per liter as just capital M. Right? So looking back at this equation, what will you need to do in order to do a problem like this? So push pause and think about that for a minute. Okay, so in this problem, we'll have to have number of moles. So if we are given grams, we'll have to change it to moles. And I'll just warn you that liters of solution is often given in milliliters, so you're going to need to convert that. Moving the decimal 3 to the left will take care of that most of the time. All right, so that's molarity. And again, if you want examples of molarity problems, then those are found on separate videos on YouTube and on the website.